When I started making this video, it was supposed to just be an introduction to Graylog, setting it up on the infrastructure and getting it to detect a simulation of attacks within a network. And then throughout that process, I realized to be able to get to that point, you have to have kind of a virtual network that can support the testing and the simulation, the attacking and the detection. So I decided instead to make a much larger video on the entire setup of my lab to get Graylog installed and using it to simulate attacks and detect possible compromise. So that's what this is. What I wanted to do was show both sides of the equation. So you see a lot of information and videos on how to attack and how to get into systems. Well, what I'd like to do is kind of combine both worlds. So that's the red side, and the blue side is how to defend, how to detect these types of things and spot them, so you can either prevent if possible and mitigate quickly if not possible to prevent. I suspect anyone getting into InfoSec could use this video. If you're new to info security and you're wondering how can I get kind of a foot in the door or how can I get a leg up on other potential candidates, one thing that I often find missing when I interview candidates is actual hands-on experience. That's not to say that you need to have worked in an enterprise network, setting up and configuring their SIM from start to finish. All you really need is the virtual environment, set up some servers, and just play around a little bit. Part of the reason I did this video is that everything that I use in this tutorial is free, except for VMware Workstation, which you could argue is a large chunk of this video. I do have a quick clip on how you can use Oracle's VirtualBox in the same capacity, just in case anyone wants to use that. So maybe you're well experienced in InfoSec, but maybe not infrastructure, SIM, monitoring, or alerting. This video could also be useful for you. Or anyone looking for a real quick crash course on Graylog, install, config, and the usage of Graylog that could benefit them. It could also be useful to anyone that doesn't care about Graylog, doesn't care about security, but is just looking for some quick pointers on how to set up a virtual environment. This is not a deep dive into Windows, Linux, or firewalls, or virtualization. It is not a comprehensive overview of Graylog and all of its features, though I do touch on many aspects of Graylog. I have tried to break this video into logical segments, but it is a big one, so bear with me. Use the timestamps below if you need to jump around a little bit, or if you're not interested in setting up any type of virtual environment, you can jump right to the Graylog sections. Or maybe you're just looking for pointers on how to set up a specific alert. You should be able to find that information below. I've also listed, I think pretty comprehensively, all the software and web resources that I've used below, in case you're just looking for those. And with all of that out of the way, let's jump into the network overview. What you're seeing on the screen is the network that we're going to be building. I'll start with the domain, fox.local. We're going to set up a domain controller, 192.168.30.10. It'll be hosting DNS, DHCP. We'll set up a Server 2019 system at .30.20. We'll set up a Windows 10 user and a Windows 10 admin system at 30.5x. We're going to set up DHCP for the 5x zone. The admin system is going to host Thunderbird, which is our free email application. And we're going to set up hMailServer on Server 2019, although I didn't list it there. Outside of the Windows domain, we've got a couple Linux boxes. We've got Ubuntu, which is just going to be a generic Ubuntu system at 30.25. And of course, we have our Graylog server at 30.100. We've also got a Kali instance local to that environment. I do have my own Kali instance outside of this environment, but I thought it might be helpful for anyone looking for some quick pointers on setting up Kali in a virtual environment. And we've got a pfSense firewall at 1.113 is the external address, and the internal address is 30.5. So we're using the .30.x/24 network for our virtual environment. I've also called out a couple IPs outside of the network. So the host OS is my host OS, hosting the entire virtual environment. It's 1.134, and I have my own Kali VM at 1.108. The only reason I call these out is at a later point in the video, when I'm brute forcing the pfSense firewall, those IPs are referenced and used. The other piece worth noting is that for the initial lab setup, you won't see the pfSense install and configuration. It wasn't until I was partway through my setup and alert testing that I realized I should probably have a firewall in any realistic virtual environment. So then I scrambled and threw a pfSense instance together. So this first little bit here is just quickly showing how to set up a virtual network adapter in VMware Workstation. So I'm going to open up the virtual network editor, and we're just going to change settings. I'm going to add a new network. This will be on VMnet 3, and this will go to 192.168.30.x subnet. We are not going to use DHCP on this network. We're going to set up our own DHCP service. And we'll just change that to .30, and that's all you need to do in VMware. As mentioned in the intro, this is that small little segment I did on Oracle VM VirtualBox. For anyone out there not using a paid version of VMware Workstation, Oracle Box is free to download. It's free to use. So I just wanted to, for consistency's sake, I wanted to show how to create a virtual adapter in Oracle Box. So a similar idea to VMware Workstation. We're just creating a new adapter. We're going to make sure DHCP is disabled, and we're going to change the IPv4 network range to 168. In this case, I'm using .31 because I do not want it to interfere with my .30. That's already set up and running. And we're just going to apply and close that setting. And just to show how to kick off our virtual machine install, I'm going to load up the ISO for Server 2019 and get that started. So not overly complex, a lot of next happening there. And now we're just going to head over to the CD drive and load the ISO onto it. So select the Server 2019 ISO, apply that setting, hit start, and I'll drag the window over to my other screen. And there we go. Server 2019 install is starting. And now that we've covered the Oracle Box network setup and the basic start to an OS install, that should keep us consistent with VMware Workstation. So this first virtual machine we create is going to be our domain controller. I'm going to go at normal speed for the first system I set up, and then I'm probably going to fly through the remainder. For the most part, it's clicking next. We're going to pick the operating system we want. We're going to pick the folders we want our virtual machine files stored in. We're going to give it a name, DCO1. Specify the BIOS, pick how many processors we want it to have, specify the RAM. We're going to use bridge networking to start. That will give it access to the actual my host OS network. We'll specify 60 gigs, and we're going to tell it not to take up all that space at once. And then we're going to edit the virtual machine and attach the Server 2019 ISO to this VM. And away we go. We'll select the Server 2019 Standard Evaluation Desktop Experience because we're going to want access to the desktop. We'll accept the license terms, or there's no point in doing this at all. We're going to select Customize so we can select the disk we want. We only have one, and then we're going to let the install do its thing. So here we are, initial install complete. We'll set our default administrator password, get logged into the system, and then a lot of what you're going to see me do is going to be used for a template. If you're going to be getting into virtualization environments and doing a lot of system setup, you should have templates ready for any systems you use frequently, just to make your life a lot easier. You don't want to have to go through a full reinstallation process every time you're deploying a virtual machine. So I quickly changed the time zone a few seconds ago, and now I'm going to just install VMware's tools. Most virtualization managers have something similar to VMware tools. It allows for copy-paste integration, system device integration, so I could use USB devices that are on my host within my virtual machine. Most importantly for me, it allows for full screen integration as well, just for a better work area. So I'm going to go ahead and enable remote desktop on all of my Windows machines, just in case I need it. I don't actually think I do anything with it throughout this tutorial. And then I believe the next thing I do is go ahead and uninstall Windows Defender. I find in attack simulation type things, for the most part, it gets in my way, which is kind of the idea behind it. And I don't plan on doing any type of Defender bypass in this particular tutorial. And now that Windows Defender is out of the way, it is going to require a reboot, but before we do that reboot, we're going to go ahead and check for Windows updates. And this takes forever, so I'm going to just let the video fly for a minute. And now that we're back on the system, I'm just going to check for updates one more time. And what we'll see here is one of the updates, or maybe more, failed to install properly. And I believe the reason that happened was because I didn't restart after uninstalling Defender. So we'll let this go one more time around. So updates should be out of the way at this point, but we're going to take one more look just to be sure. And yep, we're good. So the last thing we'll do is run Windows Sysprep to generalize the system. Sysprep is a tool that's used to generalize any PC-specific settings so that you can use it for templating and imaging. So we'll run Sysprep, we'll set it to the out-of-box experience, we'll select generalize, and we'll shut down because we're going to copy and paste this VM to be used multiple times. Once we've got our Server 2019 DC01 template set up, I'm going to copy and paste that into the same folder. We'll give it a name of Server 2019, and then we're going to load that VMware file into VMware as well, so that we've got DC01 and Server 2019. Now when you initially load Server 2019 into VMware, it's going to show as DC01 as well, but we'll just change the friendly name to Server 2019. And once we finish that, we're going to add a couple new network cards to each machine. So we have 2 network cards per machine, one for the external, what I'm going to call the WAN, and the second network adapter is going to be connected to VMnet 3, which is our 192.168.30 network. And once we've connected both of those to both networks, we're going to power them both up and configure the network settings. Now, since we ran sysprep on this machine, we're going to have to answer a couple questions before we can use the system. So general setup stuff, country, application language, accept the license, and set an administrator password. We'll do that for both systems as well. So the first thing we're going to do on DC01 is head into the adapter settings and set Ethernet 0 to the WAN, set Ethernet 1 to the LAN, and then we'll configure the, we'll disable the WAN since we're not going to be using it all that much, and then we're going to set the ID settings for the LAN. And we'll set this to our 192.168.30 address. You'll notice I set the default gateway to .30.1. That was when I didn't think I'd be routing any information through the pfSense firewall. And we set our DNS to this local machine because it is going to be our domain controller and will be responsible for name query resolution. So the next thing we're going to do is just change the name to DC01 on this system. I just wanted to make sure that the remote desktop was still enabled after sysprep. So we'll give DC01 a reboot and we'll head over and do the exact same thing for Server 2019. So mostly the same when compared to DC01. The only difference is that we're going to tell Server 2019 and the other servers to use DC01 as the name server. So you see we disable the WAN and set the LAN up for a static IP. 30.20 for Server 2019, and we'll tell it to use 30.1 as the default gateway. Again, this was prior to the pfSense setup, and the DNS server is 30.10. For each of these, I've set a backup server as my home router's DNS system. And we'll change the name for Server 2019 as well. And once that's complete, we'll reboot this system as well. Now that we've got the servers out of the way, we'll move on to our Windows 10 systems. So not too much difference here. I'm using the Windows 10 ISO, obviously. We'll put that in our lab folder. We'll set the processor, we'll set the memory, we'll set the initial network card, select the disk, and get that process going. Now we don't have a license key, but we're not going to need one. The evaluation version of Windows 10, I believe, will last for 90 days. We're going to select the Windows 10 Pro Edition since we need to be able to connect it to a domain. And we'll accept the license agreement. Custom installation, we'll pick our disk. We'll start the install process. Now we're going to select the setup for personal use. We'll just manually connect it to a domain once we know everything's set up the way we want it to be. Now I've got to say I really like Windows 10 as an operating system, but I absolutely hate how forceful Microsoft is at getting you to sign up with an online account and almost making you jump through hoops just so you can quickly get a system set up. I understand that for 99% of the population this is a nice convenience, but for me it just slows me down. So we'll just jump through some of the settings and type in a bunch of fake answers here. And we'll just do what we can to get through the rest of the setup. We'll decline most of the extended experience stuff. We'll say no to all the fancy add-ons and options. And then we'll let the rest of the setup process finish. So similar to what we did for Server 2019, we're going to get this system set up the way we want it to be set up before we run sysprep on it, since we're going to make 2 of them. So we'll install VMware tools, get that set up the way we want it to, enable remote desktop. I believe I forgot to uninstall Windows Defender or disable the Defender features on Windows 10, but I'll come back to that later. So just pop in here to change the time zone to my own time zone. I'm going to make sure to do this on every system. And then I just want to rerun updates to make sure the system is up to date. And it looks like we're all up to date. So it looks like I did remember to disable Windows Defender on the template. So we go into virus and threat protection, turn off real-time protection, turn off the cloud delivery, turn off automatic sampling submission. We're basically turning off every protection this machine has, and we're going to disable the Windows firewall. This is certainly nothing I would recommend in any type of production or even a development type template setup, but for our purposes, exploit testing and detection, it serves well. I'll also enable remote desktop settings so that I can remote the machine if I need to. And I think that'll do it for this one. And once that system is restarted, very similar to what we did on our server system, we're going to run sysprep, set it to out-of-box experience, generalize, and shut down. Alright, so now that we've got our template set up, we're going to do the same thing we did for the server systems. We're going to take a copy of that Windows 10 folder. We'll call one Windows 10 admin, we'll call the other one Windows 10 user. And then we're going to add both of them back into VMware. And what you're going to see me do very quickly, since I've sped up the video, for both of these machines is just hop back and forth, configuring them to get them set up the way we want them to for our lab. So we'll give both of them friendly names. And you can see this is sped up quite significantly at this point. And you'll see a lot of things very similar to what we had to do when we did the initial Windows 10 setup. Except I'm doing it twice now. Okay, so similar to all the other machines, we're going to add our network cards to our VMnet 3 network on both systems, and then we're going to go in and configure the network interfaces on both. The only difference for the Windows 10 systems is that I'm setting them both up for DHCP for their network addresses, and they're going to pull the IP addresses from the domain controller. My initial thinking was to do a segment in the video around DHCP monitoring. I don't believe I got around to that, but it was a good thought at the time. And we're also going to rename each system Windows 10 Admin and Windows 10 User, and then we'll reboot both of them and on to the next system. And with Windows out of the way, we're going to hop into our Ubuntu template. So most of the initial details are the same as a Windows setup. You're just specifying ISOs and locations, processors, RAM, initial network card, disk drive. And for the most part, it's a next type installation. Pick our language. We're going to continue without updating. We'll update once we get the initial install done. And initially, we're just going to let it take the DHCP assigned address off of my home network. We'll pick our disk. We'll input some initial information. We're going to skip the OpenSSH server for now. We will be putting it on anyway. I just like to do most of those things once the initial install is done. And we're going to let Ubuntu go through the install process. So almost out of reflex, the first thing I do when I'm deploying a Linux template is make sure it's completely up to date. You'll notice that I'm using an application called Tmux. It almost acts as a window manager within Linux. I'm learning to love it. So while that's running, you're also going to see me edit the sudoers file and just give my regular user permission to run any root command without a password prompt. Again, this is not recommended in production, but I do it out of convenience in my labs. Initial updates are done, so we'll just run that command one more time, and what we'll notice is we need to do a dist upgrade to grab the remaining packages. So we'll let that run through as well. We'll run up the get upgrade and update one more time, and it looks pretty clean, and we'll reboot the system, and that'll be the initial config for our Linux template. Now, the only thing I forgot to do on my Ubuntu template was install OpenSSH server, so we're just going to get that out of the way now. So we'll shut down that system, and similar to the Windows systems, we're going to take a copy of that Ubuntu template, make a copy, and call it Graylog, because the second Linux system will be our Graylog server. Once we have that in place, we'll add the Graylog server to our virtual setup here. We'll give it its friendly name of Graylog. We'll add network interfaces to both machines, similar to every other machine in our lab. And then we'll power them both on. And starting with the Ubuntu system, I'll start up a Tmux session. We'll show the IP addresses in the bottom pane, and I'm going to edit the netplan file in the top pane. We're going to disable the WAN interface, that's ENS33, and we're going to add ENS38, which is our LAN interface. We'll give it an IP address. I'll point it towards a gateway of 30.1. Put a couple name servers in there. 30.10, which is our domain controller, and 1.1, which is my host network's primary gateway. And then we'll apply the netplan. And we'll hop over to the Graylog server and do the exact same thing. And what you'll see me doing here is just pinging the Ubuntu server from the Graylog server, which proves they're both up and running on the same network. But just to be safe, I also ping the Graylog server from the Ubuntu server. Now our Ubuntu server is already properly named, but our Graylog server needs to be renamed, so that's where this command hostname ctl comes in. And then we'll edit our host file to make sure that Graylog is called Graylog. And we'll reboot that machine, and I believe that's the end of our Linux setup. And now it's time for our Kali install. So for the most part, the exact same as every other virtual machine. If this is new to you, you're probably getting the impression by now that setting up virtual machines is pretty straightforward, and it is. We'll assign the processors, the memory, the disk, assign the appropriate ISO, power it on, and hop up into the operating system setup. We use the graphical install. I find it's the easiest. We'll select English, United States. Most of this doesn't matter. I think the only things that actually change during the entire setup are the username and password, obviously. So we're going to use the entire disk, nothing too complex here. Confirm the disk setup and let Kali install. For this particular screen in Kali, I tried getting away with the top 10 at one point, thinking it would be a nice light installation, and it is, but I had to install a ton of things to get it working for me. I found the default installation to have almost everything I needed right out of the gate, so that's what I would recommend. And since Kali asks us nicely to remove the disk, that's what I'm going to do. Go in and just tell it not to connect that power on. And once the system comes back up, I'm going to log back in and make a few other changes. Now, the first thing I noticed when I logged in that really caught me off guard was the new Z shell prompt for Kali. I didn't realize that this was just released for the 2020 April release of Kali. I was using the 2020 March release on my other instance, and it had changed the font color from red to blue. But I was not aware that they were going from the bash shell to the Z shell. And so what you'll see me do through most of the tutorial is quickly jumping into Tmux, which I configured on this Kali instance to launch bash using the old shell, just because it's what I'm comfortable with. I'm generally a fan of moving forward with change, but I didn't want to spend a lot of my time struggling with a shell while I was trying to work with Graylog. So we'll let Kelly finish updating here. And we'll give this system a reboot. Now this little section doesn't have really anything to do with the network setup, the virtualization, or Graylog, but I thought I would include it for reference. If you do want the old shell from Kali, you can edit your bash RC file. So this is how I got it to work for me. And what you'll find in there is there's actually a config line for the old color system. It's commented out for the backtrack red prompt. I kind of enjoyed the blue prompt, so I copied the backtrack red prompt and just modified the color scheme slightly to be blue. And then I just commented out the existing setup. And so the next thing I'm going to do is I'm going to modify my Tmux configuration and what I want it to do. I've pulled the Tmux configuration off of my other Kali VM, but I'm going to add another line in here that tells it to launch the bash shell by default. And I didn't realize this at the time, but I think it might be doing that anyway on line 3 there. Doesn't matter, it all worked out in the end. So what you'll see is when I launch the shell, the default shell is going to be Z shell, but if I launch Tmux, it'll be the other style of prompt that I'm used to. Next, we're going to edit the Kali network configuration. So I'm going to add the second adapter in. Now, historically, I've just edited the files on disk to modify my network configuration, but I'm going to try to use this advanced network manager instead. So I've added a second interface. I'm going to call it LAN. I'm going to set it up with a manual IP address. So we did .30.200 for our Kali instance, default gateway .30.1, and I just gave it a couple name servers. And what you'll see I did here is I deleted the WAN interface, but I believe I add it back in, recognizing that I'm probably going to need it later. And it's DHCP, but I set it to disable for now. And I can ping the Graylog server. Now we're going to set up some SSH connections to our Ubuntu and our Graylog servers. We'll use Kali as our jump box. First, I apparently felt the need to change the font size in the terminal. So we'll hop into Tmux and we'll generate some SSH keys. We're going to use the same key on both servers to make life simple. We'll call that key lab. And then I'm going to use the command SSH copy ID to push that key to both systems. So .100 is our Graylog server. And then I'm going to attempt to SSH in, referencing the identity file of lab, and success. And I'm going to do the exact same thing, except I'll change .100 to .25, push that over to our Ubuntu server, and just verify login as well. So .25, and we can successfully log in. Next, I'm going to edit the SSH config file on my system. And doing this, you can create just some, I'll call it a shortcut for SSH. So host Graylog will use the host name .30.100, user kfox, and the identity file lab. And I'm going to copy that section and do the same thing for Ubuntu. And now to get into each system, I can just say SSH system name, and it will automatically reference those identity files. Perfect. So now that we've got the foundation of our network out of the way, it's time to promote DC01 to a domain controller for our Windows systems. So we're going to go in and add roles and features, select the DC01, select Active Directory Domain Services, hit Add Feature, hit Next. We'll elect to restart it if it needs to restart. I don't think it does until the end. To some, installing a domain controller can sound like an intimidating operation. It's not that complex if you're doing just a simple, straightforward kind of home lab network. And then for the promotion activity, we're just going to pick fox.local will be our domain. It'll ask for a NetBIOS name. We'll use Fox. We'll set a directory services restore mode password. Leave these as defaults. And that'll give us a couple warnings, but they're not critical for our installation. And then we'll hit install and let it do its thing. It'll need to restart, and it'll take forever to apply all these settings. But then once we get back into the system, we're going to verify that directory services has been installed properly. So we'll log back in. I always have a habit of disabling Server Manager. We'll launch Active Directory users and computers, and we've got ourselves a domain controller. Now we'll install the DHCP service on the domain controller. So same idea, go into Server Manager, select the tool you want to install, in this case DHCP server. I think I mentioned it earlier, but my initial intent was to do some sort of monitoring around DHCP. I don't think I used it at all. Not that it matters. So once we've got the initial service installed, we'll launch the DHCP MMC console, and we'll create our initial scope. So new scope, we'll give it a name. It's called fox.local scope. I think we said we'll use the 50 range, so 3050 to 3059. We have no exclusions. We'll configure some options now because we need it to reference our router. We need it to reference our DNS server. And then I think I realized I couldn't hit 1.1 because the WAN interface was disabled. So we'll go ahead and temporarily enable that interface since we are using it as a backup DNS server. And we've activated the scope, and we've got the initial startings of a DHCP service in place. The next step is to join all of the systems to the domain. So we'll start with the 2019 server. And this is just a matter of accessing the computer properties and changing it from a work group to a domain. It needs to be able to hit the DNS server and the domain controller, and if you can do that, it'll ask you for credentials, and it shouldn't be much more complex than that. And after a reboot, you'll be in the domain. Now we'll do the same thing for the Win10 admin and Win10 user systems. If you've noticed, they went to sleep. In the meantime, it's one of the things I don't like about my Windows 10 templates. I always forget to change the power settings. So you'll probably see that's one of the first things I do when I log in. Yep, there we go, right to the power and sleep settings to change them to never. Now I'm going to verify the IP settings. The DHCP should have kicked in, so we should be good there. And we should have no issues joining the domain for both of these systems. And we'll go back to the domain controller, and we can see both systems have registered with DHCP. And inside Active Directory users and computers, we should be able to see all of these systems. So 3 of them are in the computers OU, and we've got our domain controller and our domain controller OU. Our domain is set up. Wanted to take a few seconds to set up a share on the domain controller that's going to be used to distribute the software to my other Windows systems. So you see I'm going to copy in, I think, everything we need. Put that on our domain controller. I'll extract the Sysmon information. And we'll set the share up. We'll just set it to everyone full control, and then we'll set the NTFS permissions. I think I did domain users read only. Yep. The next thing we're going to do is set up our hMailServer on our Server 2019 system. It will act as our mail relay. Now I know hMailServer has a .NET prerequisite, so you'll see I'm going to go into Server Manager and install that feature first. So we'll copy hMailServer over from our domain controller share, head into Server Manager, select the .NET Framework 3.5 feature installation and let that go. And once that's complete, we can start the hMail setup. This is pretty straightforward as well. I don't think I actually modified any of the settings out of the gate. Give it an administration password. Log in to the admin console. And we'll create our initial fox.local domain. And then we're going to create a couple of accounts. My own account, kfox, and we'll create a Graylog account as well. That'll be used as a sending account for the Graylog server. And then we'll just run a netstat and verify SMTP, POP, and IMAP are all running. And we see 25, 110, and 587. So now we're going to try to run Telnet to send a test email, and I realized Telnet wasn't installed. And then in trying to re-enable the WAN interface, I think I realized the LAN gateway was getting in my way. So I tried to change the metric by adding a route to the LAN interface. And I did it right, I believe, but I figured the quickest way was just to reboot the system for the route to take effect. For some reason, I always struggle with Kali Linux and changing network information. So I'll log back into the box and you'll see in a moment how the routes look. So 1.1 has a default metric of 100. That'll work for us to get out to the internet, and we have routes to our .30 network as well. Now we can install Telnet. So let's try a test connection to our Server 2019 system. And it fails. And it's because the firewall is getting in the way, so we're going to add an application exception to the inbound rules. So we'll select the hMail application and set it for all profiles, and that should let it through. And before we launch our test email, we're going to create a regular user and get Thunderbird Setup on the Win10 user's desktop. So let's create a Kevin user, give him a password, let his password never expire. And we're just going to add that user to the administrators group of the Win10 user system from the domain controller. And I'm doing this just so I can install the application as that user without having to elevate credentials. Honestly, it's just because I'm lazy. So we'll log into the admin system. I think I said it was the user system. That was a mistake. Copy over the Thunderbird application and get that installed. Just do a standard installation. And we'll set up our connection to our mail server. Now, I'm not sure how I thought it would find my mail server automatically. It didn't. So then we just changed the manual settings to the actual IP address. We could probably set up a DNS name for mail.fox.local or some MX records, and I'm guessing it would work. But doing this was just as well. And we don't have any SSL or TLS set up, so it gave us the warning. And we've got ourselves an inbox, so let's go test our mail message. So using Telnet to do this, you can Google test email over Telnet, and there's a ton of documentation on how you can do this. The new thing I learned was that the login screen is in base 64. So I actually had to convert my kfox at fox.local to base 64, and my password, which is password bang as well. And for the login, I had to paste that base 64 converted username and the base 64 converted password into the terminal for it to authenticate me. So not plain text, but certainly not encrypted. And then we'll just specify some mail fields. So we're sending from a test account. We're going to send it to my user, kfox at fox.local. And then we'll enter a subject line, followed by some random data. And the email's been queued for sending. So let's quit Telnet and see if we receive that email. Oh, it's already there. Perfect. And now it's time for the Graylog installation. So we're going to hop into our account machine and open an SSH session to the Graylog server. We're going to be following Graylog's Ubuntu installation guide almost verbatim. We've got the prerequisites to install, MongoDB, Elasticsearch, and then finally Graylog, and some slight modifications to the configuration file. The only deviation I think I make from the actual installation documentation is I'm not installing the enterprise plugins. I'm just going to do a pretty bare bones installation of Graylog. So this is me once again editing the YAML file for the network to allow it to download packages. And you can see at this point I'm just opening up for both Graylog and Ubuntu. I'm allowing them access to the WAN. And I think that's when I got the idea that wouldn't it be nice to put a firewall on this virtual network so that my systems could properly get out to the world. So we'll start by running apt get update and upgrade as per the documentation. And then we've got our prerequisites to install. Once those are complete, we're going to copy and paste the next piece from the documentation. That is the installation of MongoDB. Once that's complete, we're going to set MongoDB up to auto load every time the system reboots, set it up as a service, and then we'll run a command to verify that the service is up and running. We'll do this for Mongo, Elastic, and Graylog. The next component to be installed is Elasticsearch. So again, a lot of copying and pasting right out of the documentation. As per the documentation, there's some slight modifications to Elasticsearch's YAML file. Nothing too complex, and then we'll set that up as a service and set it to auto start as well and verify that it is up and running. And last but not least, we've got the Graylog piece of this puzzle. So as you can see, I believe I show a highlight of what I'm actually installing. We won't be doing any integrations, plugins, or enterprise plugins. Just the basic install. And once that's done as per Graylog's documentation, there are two explicit values that need to be in place before it will work. That is the password and the SHA-256 representation of that password. So we'll set the password secret. I think I selected password. Again, not best practice, but for my own virtual lab, it'll suffice. And the documentation does provide instructions on how to generate the SHA version of that password, as you can see there. So we're going to copy and paste that value into the root password SHA-2. And then I think the last change I made was to allow the web interface to be hit on any interface. So I'm just going to bind it to 0000 instead of the local interface. last thing we'll do is set Graylog up to run as a service and ensure that it is up and running. And we're done with the Graylog installation. Now we're going to head over to our Windows 10 admin system, launch IE. We'll connect to the Graylog IP address, .30.100, port 9000. Log in with our default credentials, admin, password, and we'll just take a quick look around, make sure everything's okay. So we've got one alert, and that's because we're not running any inputs yet. We'll be using search quite a bit. We'll set up some streams. We'll create some alerts. I think I set up 1 or 2 dashboards. Otherwise, a fairly healthy system. And now I'm just going to set Graylog as my default start page in IE out of pure laziness. Now we're going to set up some inputs in Graylog. Inputs are the way to get data into Graylog. Without them, you're not capturing anything. So we're going to set up 2 inputs. Gelf UDP, that's the Graylog extended log format. It's like a better version of Syslog. It supports formatting, data types, compression, extended log, message length. We're going to set that up on port 12201. And we're going to use this to capture Windows events, I believe. So no issue getting that one up and running. Then we're going to set up a Syslog UDP. This will be used to capture our Ubuntu Syslog events. Give that an appropriate name. It'll bind to port 514. And we'll save that, but what you'll notice is the input won't start. And the reason for that is because by default, Graylog is not running as a privileged service, and so it cannot bind to any port below 1024. Now I think the cleanest, there's a bunch of ways to fix this, but the cleanest fix I could find was to edit the service file directly. And the fix was just to add this ambient capabilities flag, capnet bind service, which will allow it to bind to any privileged port that is available. So we'll save that file and restart Graylog. We'll give Graylog a minute to come back up. And we should see that that service is up and running. And we'll stop it and start it just to be safe. The next step is going to be setting up an NXLog, our event collector, on the domain controller, but first I wanted to show how you can go into Graylog and delete all messages out of an index. So you're just going to run a curl-x delete command towards port 9200, and the default index is Graylog 0. And you can see if I run it against Graylog 2, it errors out. You'll probably see me do that throughout the video. I wouldn't recommend it for production, but for testing purposes, it's helpful. So we've hopped up over to DC01 and we're installing our NXLog service. That's a next install. And then we're going to go over and edit the configuration file. So we're going to start NXLog, and I just wanted to show in the actual log file for NXLog, it will tell you any issues it's having. So if you're editing the configuration file, use that log. It's very verbose if it runs into issues. So we're going to add some sections to this file, and I just want to talk through them. This is what we've added. We've added the Gelf module, which will allow us to send Gelf messages. We've added an input called sec event log. And this section will allow us to pull events from event logs. It's composed of queries, XML queries, directly from the event log. So you can hop into the event log and pull the query out of there if you'd like. But you can see for our purposes, we're selecting every event out of the security log to start with. We've also got our output, which is our Gelf UDP. It will be using the output module, that's OM UDP, pointed towards our Graylog server at .30.100 over port 12201 and using the output type of Gelf. And finally, we're routing the sec event log into the Gelf UDP. You need this route event to tell the events where to go. So we'll save that file and restart our NXLog service and just double check the log file to ensure that everything started up okay, and it did. No errors, no issues. So back over to our Graylog server, and if we go to streams, we should see some events coming in here. And there we go. We see what looks like a logon event, maybe an account log off activity. We see the fields being parsed properly. That's Gelf doing that. So we're going to go set up a test index now that we'll use for testing. And the purpose here, for my purposes anyway, is just so that if I'm deleting an index, I can just delete the test index instead of all the messages in the Graylog index. So we're going to create a new stream that those test events will go into. And we're going to match the Windows security events into the test index to start. And I checked the box there to remove them from the all messages queue. So we're going to set up a rule here for the stream. We're going to pull a message from the Gelf UDP input, and that'll allow us to quickly parse some information to make sure we've got the right logs going into this stream and this index. So let's use the source name. We'll add a stream rule. Source name must match Windows security. And let's add channel as well, just for fun. Channel must match security. Perfect. So let's start that stream. And now we should be pulling events that are coming over the Gelf UDP that match that criteria into our test index, which is going through our Windows security event stream. And they should not be hitting our all messages stream. So nothing showing, and if we go to Windows security events, well, nothing there either. And there we go, we've got some events. But they're not in the all messages. Now for anyone that's worked with Windows security events, you know it can be quite noisy. So what we're going to do is define a variable in our NXLog configuration file that holds all the events that we do want to see. Just for reference, you'll notice 4672, special privileges assigned to new logon, is not in that list. And this is the website I pulled the list from. Seemed to be a pretty comprehensive list, but of course you'd want to tweak and tune this for your environment. So we'll go down to our input event here and we'll add an exec clause. And what we'll instruct that to do is to drop any events that are not in that list. So if EventID not in our defined variable, security event IDs, then drop. We'll save that. We'll restart our NXLog service. Check the log file for NXLog, ensure there's no errors, and head back over to Graylog. First we'll delete the index, make sure it's clean. We should have no events. And then I believe to force generation of events here, I just locked myself out of the domain controller and logged back in. And that should be enough to generate a few events. What I'm looking for here is to ensure that event 4672 does not appear. So we'll see a few messages here, but I did not see 4672. And just to verify, we'll open the event viewer on our domain controller, and you can see a couple 4672s there, but they did not get pulled over into Graylog. Now that should work well for most of our Windows systems, but specific to our domain controller, we're going to see a lot of log on, log off activity because it is a domain controller. So we're going to filter those events out directly at the input section. So we're going to update our select path criteria to be the security log, but where the event ID is not 4624 and not 4634. And not 4672, which we're actually already dropping. We'll restart that after saving it, verify that there are no errors. And what you'll see you can do here is I'm actually just going to copy that, and you can go into Event Viewer. I'm not sure how many people know this, and you can edit. Normally you could do the event ID there. Most people know that. But if you go to the event log and go to the XML, you can edit it directly. Now, if you're doing this, it doesn't allow you to use the easy section anymore, but you can paste XML queries there and it will have the same effect. So back over to our Graylog system, we're going to clear our test index once more. And then we'll generate a logon event. Now, ideally, you probably do want to know if someone is actively logging onto the domain controller. But for our purposes, we're going to remove most of those events. And you'll see we did catch the failures, but we've stripped out the other events. With the domain controller setup out of the way, we're going to deploy NXLog and the configuration file across all of our Windows systems. So first we'll create a share where we'll put the NXLog installation file, and we're going to copy our configuration file to be deployed everywhere. And we're going to modify that configuration file slightly because we actually do want those logon event IDs on our non-domain controllers. So we'll save that and we'll hop over to each server and pull the file and the installation over the network. I'm going to quickly run through the NXLog setup on all 3 Windows systems. And there are better ways to do this type of software deployment. You can use group policy or some other distributed system, but this works for a lab environment. And now we're going to access the administrative share on each system to effectively copy the configuration file to Server 2019, Win10 admin, and Win10 user. Again, there are better ways to distribute files in an enterprise environment or even a small network, but this works for our lab. And then finally, we're going to open up PowerShell and instruct the service on each system to restart. We could have used PowerShell to distribute the files as well. We could have wrapped all of this into a PowerShell script, but this will work for our purposes. So we're going to get the service from Server 2019, NXLog, and we're going to ask it to start. And then we'll do the same for Win10 admin and Win10 user. Just replace the Server 2019 with Win10 admin, and ditto for a Win10 user. And then we'll just query for the status of the service on each system, make sure it's up and running. And then we'll head on over to Graylog and ensure that it is receiving log files from each system. And if we refresh our search there, you can see Win10 admin in the source. We'll see Win10 user there. We see DC01. I don't see Server 2019 anywhere, but I know it makes an appearance later. So that was a slight oversight on my part. But we'll fix that. And the last thing we'll do before we move on to Sysmon installation on our Windows environment is we'll just redirect the Windows security events into our default index set, since we're no longer testing the collection of those events any longer. The next thing we want to do with our Windows systems is get Sysmon on all of them. So we're going to copy a Sysmon config. We'll take a quick look at it. Try not to be intimidated by it if you've never seen a Sysmon config this big. If you take your time and go through it, it's fairly easy to understand what it is and is not doing. There are different event IDs through Sysmon. This is filtering in and filtering out meaningful events. You'll see there's an event ID 2 for file creation, retroactively changed, time stomping. Event ID 3, network connections. Pulled this configuration from SwiftOn Security's GitHub site. A Sysmon configuration file for everybody to fork. So out of the box, it'll behave fairly well, but obviously for every environment, you're going to need to tweak and tune it to suit your needs. But for this lab and for my purposes, it should be able to detect everything I need it to while keeping the noise to a relative minimum. And Sysmon's website it's now Microsoft sysinternals tool. Again, obviously the GitHub configuration file is free, and Sysmon itself is free for use. Sysmon is a utility that can dig right deep into all the events that are happening on a Windows system. We'll just give you better visibility, and we'll show an example of that later. So we're going to copy that Sysmon folder to the domain controller to start, but we'll eventually put it on all systems. And we'll install the 64-bit version of Sysmon. And there's not that many options here. It's mostly about dumping the configuration, installing it, uninstalling it. So we're just going to install it with the configuration we downloaded, and we'll accept the end user license agreement. And done, we've got Sysmon installed. And we'll just pop into our event viewer to ensure we are receiving those events. So we'll check out the Windows Sysmon operational channel there, and you can see we are getting event ID 1, event ID 5, event ID 4, 16, etc. We're getting Sysmon events into our event log. And EventIDs 22 can be, they're DNS queries. They can be pretty noisy. I'm not sure if I actually filter those out down the road or not. So let's go do that exact same process on our other 3 systems. I'm going to speed the video up a little bit. And we're just pulling the Sysmon folder from our DC01 file share. And that should do it. We should have Sysmon running on all 4 Windows systems now. The next step is to update our NXLog configuration file to actively ingest these Sysmon events. So we could add it to the same input as sec_event_log, except for the fact that we're actively screening out event IDs on that one. So we're going to paste a new section in here, and we'll call it Sysmon event log. And you can see there we're referencing the Microsoft Windows Sysmon operational channel, and we're pulling all events from that. Now we're pulling all events from that, but the events are being screened out by Sysmon's configuration before they hit the NXLog path. And if you're looking for how I got that path, this is where I went. You can go into event log, Microsoft Windows Sysmon operational. And then we're just going to update our sec_event_log Gelf UDP route, and we're just going to add Sysmon event log to it as well. So it will send both of these to the Gelf UDP processor. So let's restart NXLog, and we'll hop into the log file of NXLog just to verify there are no issues, and there are not. So if we hit search, we can already see some process create IDs there. And that one is coming from the Microsoft Windows Sysmon operational. I'm going to create a permalink to this event, only because I'm going to use its ID to generate the stream for these events. You'll see what I mean in a moment. So if we create a new Sysmon event stream, we'll have that go to our test index, temporarily remove all matches from the all messages stream, and we're going to set up a rule so that we can pull the proper events into here, because we don't want to be pulling our normal Windows security event logs into this as well. So I loaded that message. I loaded a recent message from the Gelf stream, but you can go to message ID and you can actually reference a single message ID. And the reason you might want to do this is if you just load a message, you could get any message from that stream. I believe it pulls the most recent, which might not be the one you want to reference. So we'll paste that message ID there and put the index in, and it will load the message we want to reference. And you can see this is the process create on the Microsoft Windows Sysmon operational channel. So we'll create a couple rules. The first rule will be based on the source name, and that will be the actual Microsoft Windows Sysmon. And that really should be enough to get the right messages, but just for fun, we'll add a second rule in to reference the proper channel. And we'll start that stream, and now any new events coming in should get filtered into that stream and pulled out of our all messages stream. And you can see it's currently empty, so I'll go and generate some logon events. Hop back over to Graylog and refresh that view, and we should see information hitting this stream. Now that Sysmon has been configured on DC01, we're going to update the configuration file on our shared folder so we can distribute it to the other 3 Windows systems. So all we need to do here is copy the piece for the new EventLog channel, which is the Microsoft Windows Sysmon operational channel. So we'll copy that from our DC01 config, put it in our shared configuration. We'll also update the path. Save that file, and then we'll open up PowerShell and we'll use it to distribute the file and restart the services on the 3 systems. So we use a copy item commandlet. Specify the source as our NXLog local conf file and the destination as the remote admin share to that file. So done for server 2019. Change that name to Win10 admin, and then we'll do it one more time for Win10 user. And similar to previous, we'll specify the get service command to pull the remote service and pipe that into the restart service commandlet. For server 2019, Win10 admin, and Win10 user. And once that's done, we should be able to go over to our Graylog server, and if we refresh the Windows Sysmon event stream, we should be able to see events from, there we go, Win10 admin, Win10 user, DC01. Do we see server 2019 in there at all? Yep, there it is. So all 4 systems are reporting in the Sysmon channel. And now that we have that working, we're just going to update our Windows Sysmon stream, and we'll remove it from the test index and repoint those events at the default index. And we'll uncheck the remove matches from all messages stream. Now that we've finished setting up our Windows systems, both the security event log and the Sysmon event log streams, we'll move over to our Linux system, and we'll start by SSHing into the Ubuntu box, and we're going to install AuditD, which is responsible for writing audit records to the disk, and we'll eventually be leveraging Rsyslog to send those events over to Graymon. And we'll just take a quick look at AuditD's event log or event file to verify that it is actually receiving events, and it is. Now, the other thing I came across when I was originally going through this was Syslog was being filled with a lot of failures from the multipath service, and you can see they're refreshing there on the screen, and that was just bloating Graylog's event log. So the quickest way I found to fix this, there are a few ways I came across online, is to edit the multi-path configuration file and just blacklist those entries from the file. So you can see that I'm adding a blacklist section and asking it not to include dev node. I think I specify SDA 0 through 9. And once that's complete and saved, we'll restart the multipath service. And then if I tail the syslog again, we should not see those events hitting the log file. And they won't be going to Graylog, which is what we want. With AuditD installed, we're going to now edit our syslog's configuration file. And we're going to load the input file module. So that's load IM file. And then we're going to create a new AuditD syslog configuration for our syslog. So we'll just call that 100-auditd.conf, and we'll make note that the input type is IM file, which was the module we loaded in the main our syslog configuration. We'll point that at the verilog audit.log file. It is an AuditD tag that we've appended there, and then we'll instruct it to forward those events to the target syslog server, so 30.100. Port 514 and sending over UDP. So we'll save that and we'll restart syslog. And then we'll hop back into our Graylog system, and if we refresh the events, we can already see that the Ubuntu system is sending AuditD events over our syslog stream. Now with AuditD, you can get into some pretty fancy things, and we'll get into that in a minute or two. But first we're going to set up the Ubuntu syslog stream. That's going to collect our AuditD and syslog events from the Ubuntu system. We're going to skip the whole test index stuff this time around. We'll just send everything to the default index. We'll load a message from the UDP stream, and we'll make one of the rules to be the source from Ubuntu, and that should be enough to get everything going into that stream. And if we give it a quick test, SSHing back into the system should be enough to create some events, and it is. So one of the many things you can do with AuditD is monitor file level access. So for this particular example, we're going to modify the rules so that anytime someone touches the etc password file, PASSWD, it will create some sort of an event and tag it with a key value in Graylog. So the -PWAR is for write, append, or read type access. The -K is the tag being used. So we'll restart AuditD. And if we read the etc password file, which is common during any type of an attack if you get access to the system, and if we reset the search there, what you can see is that top event had the key PSSWD access. So we flagged on that, and we could subsequently set up an alert on it. Now that we've done a proof of concept with AuditD against the etc password file, we're going to put in place a more comprehensive AuditD configuration file. Now this is based on the Center for Internet Security's Ubuntu 2004 benchmarks. It will be extremely noisy, and it will produce a lot of results. It would need to be tweaked and tuned in any environment, but for our purposes it'll work just fine. So I'll pull the sheet over onto the window here, and we can take a quick look here. You can see there are rules for date and time modification, user group information modification, network activity, MAC modifications, login, logouts, etc. So that's the sheet we're going to use. And And I think I actually pulled the website up on the screen here. Yeah, there it is. So Center for Internet Security, there are a ton of benchmarks here. It's a pretty good resource for that type of information. So we're going to copy that entire file and we'll paste it into our audit rules file. That commented out E2 line makes it so that rules cannot be added or changed or modified without a reboot. The thinking is that you would find a reboot in your environment. So we're going to restart AuditD. And then we'll take some sort of action that we know would trigger AuditD policy. So in this case, I'm going to elect to edit the sudoers file. So I don't think I actually need to make any changes as long as I save the file, which will trigger some sort of a write. That should be enough for us. And if we go back over to Graylog, we'll refresh the entries here. And what we can see there on the third entry is SC sudoers has been accessed for some reason. And you can create alerts and alarms based on this information, of course. And we can see right there, user sbin vsudo was accessed. And this is the part of the setup of my lab where I realized it might be nice to have a firewall. So you can see I'm just flying through the install of pfSense. It is a free firewall. So we've got two NICs hooked up to it, one for the WAN, one for the local LAN on VMnet 3. And the install is fairly straightforward. Obviously, pfSense can be incredibly complex like any firewall, but for our purposes, we're not really going to do much with it. So that was mostly a next install, and we're going to select no for the web shell, and we're just going to hit reboot there. And once we're in, all we really need to do to get it going is configure the LAN interface. The WAN is set up for DHCP by default. And there we go. So we'll select option 2 to configure our interfaces. And we'll start with the LAN interface. We'll enter the IPv4 address, so that'll be .30.5. And the subnet bits will be 24. That'll be the equivalent of 255.255.255.0. For the upstream gateway, we don't want any on the LAN interface, so we'll just hit enter. And we're going to skip IPv6 configuration, and we do not want it serving DHCP addresses since DC01 is already doing that. And we'll set the web configurator to HTTP. I'm just not sure if it's going to ask for SSL information or not. So we'll let that reload. And it looks pretty good. It got a DHCP address from the WAN, and we'll head over to our Win10 admin system, and we'll see if we can hit the web configuration portal. We'll log in, we'll jump through some of the initial setup steps. Again, nothing overly complex here. We'll leave the hostname as pfSense. We'll set the DNS server for our upstream router, so 1.1. We'll set the time zone to America, Toronto. Obviously set it to whatever time zone you're in. And for the WAN interface, we'll leave that as DHCP, and I don't think there's anything we really need to configure here. And on the LAN interface, we've just done that configuration, and for the web GUI admin password, we'll just set that to the password we had already configured. And we'll hit reload and let that restart the system. And we've got our firewall configured. And now that we've got a proper firewall in place, we can disable the WAN interface on all the systems and set the LAN interface to use .30.5 as the default gateway. So you can see I'm going into DC01 and just disabling the WAN and setting the gateway to 30.5. We'll open up a command prompt and make sure I can ping Google, and I'll run a trace route just to be sure. And you can see it's hitting 30.5. It's the first hop. We'll hop over to server 2019, do the exact same thing. Run a trace route. Looks good. I think I remembered about partway through that these two systems were getting their IP addresses via DHCP. So back over to DC01 to change the DHCP options. So this is fairly straightforward. You just select the previously set up scope and go down to scope options, and then for the router, you're changing that from a 30.1 to 30.5. And then we'll head over to the Win10 admin and Win10 user systems and just run a DHCP renewal to ensure that they get those settings right away. And the trace route shows that they did get the settings. Should be the exact same thing on the Win10 user. And for the Ubuntu and Graylog servers, I use the Kali box as the jump box, and I just use Tmux to create a couple windows and SSH'd into both of those systems. And I just ran the changes side by side. So I'm going to edit the net plan files on both systems. And what you're going to see here is I'm just going to comment out the WAN interface, which is ENS33, and change the gateway to 30.5 on both systems. And then I'll just reapply that YAML file. And the routes look good. And I think I tried to run trace route and it wasn't actually installed. And so the odd thing here is that the fact that I'm able to apt-get install trace route tells me everything I need to know. I am hitting the internet, but I felt the need to run the command anyway. And then for the Kali system, I use the advanced network configuration, disable the WAN interface. And for the LAN interface, we just need to change the gateway to .30.5. And I struggled a little bit with this. For some reason, the save was showing as disabled. And I think it was disabling that route that eventually allowed me to save it. And then for some reason, with all my computer knowledge, I still struggle to properly reapply network changes on any Linux system. I tried to restart the network manager, and that didn't seem to do it, so I just decided to reboot instead. And once the system comes back up, I'll pop back into a terminal and just verify that the route looks good. And .30.5 is our only gateway. And we can ping Google. All systems done. Now that we've got pfSense configured and all machines pointed towards it, I'm going to take a quick minute and add some resources to the Graylog system. I realized through some of my testing that it wasn't quite holding up, so I'm going to double the memory and double the processor count. Make sure Graylog's back up and running. We've got events coming in. So first we're going to create a brand new input for pfSense. It's running Syslog UDP as well. but I wanted to have all the firewall events completely separate from everything else. So we're going to put that on 11514. We'll get that running. And then we're going to create a new index as well for pfSense. So it will eventually have its own input, its own index, and its own stream. So we'll save that index, and then we'll create a pfSense stream as well. And we'll assign it to the pfSense index. Then we're going to create a new rule for that stream. And we know that the source is going to be pfSense. Now this is a bit backwards because I'm realizing now that I missed overwriting the source, but you'll see me go back and fix that in a moment. So we're going to start that stream. I'm going to go back to the input, and I'm going to edit that and ask it to override the source to call it pfSense. That way we know all the events coming in on that input are tagged with the pfSense source. And we don't see any events yet, but I believe, log into the firewall. We're going to head over to the system logs, and we're going to configure the syslog settings on this side. So we need to enable it. We'll give it an IP and a port. So that'll be .30.100 port 11514, and we're going to select system and firewall events. We still don't see any logs, but I believe I generate some pings from my external interface to its external interface, and we'll see those ICMP echoes fail. And then I believe I also try an RDP session, which gets knocked down as well. And what you can see here initially in the logs is that the data is going in, but it's not neatly formatted. It's one big line of information. So the next step we're going to take is we're going to configure our extractors on the pfSense input. So we're going to import some extractors, and you'll see in a minute I should show the website. I grabbed them from this GitHub repo. Someone's already done the hard work of writing all the extractors for pfSense going into Graylog 3. So we're just going to add those to the input. And if we get some more traffic, and if we take a look at it now, you'll notice there's tons of information formatted very nicely. I'm going to remove that bar graph just to fit more on the screen. And having this information granular like this makes it a lot easier to search on, create alerts on, etc. So we've got our entire environment set up the way we want. We've got Windows systems, Linux systems, we've got a firewall, we've got logs going into Graylog. Now it's time to start generating alerts against the information we're receiving. First, we're going to set up the Graylog configuration to allow email alerts to be sent. So we'll navigate down to the email transport section. We're going to allow emails to be sent. So we'll leave email enabled to true. We'll set the host name to our server 2019 IP address. That's 30.20. That's the system we set the hMailServer up on. Port we'll leave at 587. We'll set the username to Graylog at fox.local and the password to passwordbang. And the email is going to be coming from Graylog at fox.local. So we'll save that. We'll restart Graylog. Wait for Graylog to reload properly. And once that's done, we'll head over to create a new alert. So we'll start by creating a notification. These are the templates that will be used for any alert. So we'll call it our email alert. It will be an email notification type. It's going to be coming from Graylog at fox.local. We'll leave the subject alone. The recipient's going to be kfox at fox.local. And we're not going to mess around with the template at all, but you should be able to see that there's probably a lot you can do with that. and we're going to send the test notification. And if we hop over to our mail, you can already see in the bottom right there, we've received it. So we've successfully got mail relay set up in our environment. And we'll create that alert, or that notification, sorry. The first alert we're going to set up is a Windows brute force alert. And this is going to send an email alert out if we see a bunch of failed authentication attempts. So we're going to use crack map exec on our Kali instance. It can be used to brute force a bunch of services, but we're going to point it at SMB on .30.20. That's our Server 2019 system. We're going to use the domain Fox, the user administrator, and we're going to use the Rocky password list. That probably generated a couple hundred events right there. And as you can see on the left-hand side, there's a bunch of an account failed to log on events. So that's sufficient for a proof of concept. So we're going to take event 4625 there, and we'll use that as our filter for our alert. So head back over to alerts, and we'll call this one Windows brute force. Now the condition we're going to set, it's going to be a filter and aggregation condition type, and the search query is going to be EventID 4625. And you can use the pane on the right-hand side to verify that you're actually receiving messages. We'll filter the stream to the Windows security events because that's where we know they'll be coming from. And we'll set our search within the last 1 minute, and we'll execute that every minute. And we want it to aggregate on the count that it receives. And we're going to select greater or equal to, and I'm not sure what I put here, 30. It sounds reasonable. So 30 failed logons within a minute. We're going to add an email alert notification. And the grace period is used so you're just not hammered with alerts. We'll set that to probably 1 or 2 minutes. 2 minutes, and the message backlog indicates how many messages you want to see in the alert. So it'll give you details on what triggered the alert. So we've created our alert condition, so now we need to test it. So back to the Kali machine, and we'll load up crack map exec again, and we'll do the same thing we did before. Fire a couple hundred events, head back over. We can see that those events are going into the log, and we'll wait patiently for our email. And there we are, a Graylog event notification, Windows brute force triggered. So if we take a look at that, it'll give you all the details that were indicated in the template, and that's the message backlog you're seeing there. So we've asked it to include a couple of events that triggered it, and you can see audit failure, the remote IP, the source IP is in there, target domain name. So we've successfully detected a Windows brute force attack. The next Windows alert we're going to create is going to be based on modification of the domain admins group. So if you're running a Windows enterprise environment, it shouldn't matter how big or small you are, you should be watching for this event. I would expect any system administrator or security professional would like to know if the domain administrators group has been modified in some way. So you see there, I just added my Kevin F user to the group, and we can see that member was added to a security enabled group. That's the event we're going to be looking for. I believe the event ID was 4728. It shows details for the domain. It shows the target username was domain admins. That's probably enough for us to go on. So same thing as before, we'll take that information, we'll head over to our event definitions, and we'll create a new one. Member added to domain admins, sounds descriptive enough. Filter and aggregation, we'll set the search query to event ID 4728. We can see it successfully finding the information. Target username, domain admins, and we are still getting hits on the right hand side. and we'll ask it to search. I believe we did every minute on the minute. And we're not going to do aggregation, we're not going to do count. We want it to trigger if it sees any results. So we'll add our email alert again. We're going to leave the grace period empty because we want to see everything, and we'll ask for the message backlog. So we're going to filter on EventID 4728 just to see what we can see. And that event happened 4 minutes ago, so we're going to go and take myself out of the group, which would trigger a similar event. We're going to add myself back in. That's what we're watching for. And you can see the event triggered. And now let's see if the email comes. And there we see an email alert, member added to domain admins. Take a look at that. It's got all the relevant information. And you can see that Kevin F was added to the group, domain admins. Now for the next alert, we're going to see where something like Sysmon can really help out. So we're going to run a scenario here where we're going to use Meterpreter or a Metasploit console to get a shell on the system using known credentials. So it's going to generate a logon event for sure, but it might not necessarily show us something suspicious. So we're using the Windows SMB psexec exploit, and we're going to set the remote host to the 2019 system. We're going to set the local host to 30.200. That's our local Kali box. The domain is Fox, the user is administrator, and we're going to set the password to the legitimate password. And if we run that, we've got ourselves a Meterpreter shell. So if we hop back into Graylog, and we're just looking at security events right now, we do see a successful logon, but that in and of itself might not look all that suspicious. A single legitimate logon event. However, if we look at the Sysmon events we're collecting, we'll see a few interesting things here. A couple process creates, a file created, but if you take a look at the actual command line that's been run, you'll see it looks definitely not legitimate. It's a bunch of gibberish PowerShell, something a normal user won't be running on their system. And you can see a suspicious looking PowerShell file has been created in the temp directory as well. So let's use one of those PowerShell commands, and we're going to base an alert off of one of those. So if we head over into our alerts, we'll create a new event definition, and we'll call this one suspicious PowerShell. Filter and aggregation. We're going to filter on Sysmon events. We're going to look back the previous 15 minutes only because we want to be able to see one of the events and make sure our query is typed in properly. So EventID 1 is process creation. And we're going to set the command line equal to kind of a star PowerShell star hidden and star from base 64. Now that would need to be fine-tuned for any environment, but that's what we had seen in our logs. We'll look back over the last minute, and we'll execute that search every minute, and we're only interested if we hit any results. So we'll select our typical email alert, set the grace period to a minute or two, and we'll set the backlog to at least one message. I probably put in a few more though. Nope, just one. And there's our event. Or sorry, there's our alert created. So we'll hop in, take a look at the Sysmon event stream. We don't see anything in the last 5 minutes. So let's hop back over to Kali and we'll rerun that exploit. So we've got a legitimate Meterpreter shell. and we were just about to go search for events, and the alert hit the inbox. So if we take a look at that, it's got all the information from the alerts. You can see the PowerShell command being run there. And this would give a security team enough information to start doing some sort of an investigative analysis. Now turning our focus over to our Ubuntu Linux, we're going to brute force this system using Hydra. We'll set the username to kfox, the password to the legitimate password, and I'm going to hit the SSH service. So I'm doing this just to prove that Hydra's working and I can successfully log in using Hydra. And success. And if we head over to the Graylog system, we will see, or we should see, once we filter most of the events out, our accepted password for kfox from the Cali IP. So if we head back over to Cali, we'll rerun that Hydra attack, except this time we're going to use the rocku password file just to generate a bunch of failed logins. So we only need to let that run for a few seconds, and it probably threw a couple hundred or a couple thousand at it. And we can see a lot of connections closed, and we can also see a lot of failed password for kfox. So that's what we're going to build this alert logic off of. So we'll head over to our alerts, create a new event definition, call it Ubuntu SSH brute force, filter and aggregation. We'll filter on our Ubuntu Syslog message stream. We'll look back 5 minutes just so we can make sure our query is typed in correctly. We'll filter on the facility of security/authorization. And we're going to filter against message failed password 4. That should give us enough ammunition to collect some events. So same as some previous testings, we'll look back. On this one we did 5 minutes every 1 minute, and we're actually going to filter on an aggregation of count. We want it to be greater or equal than, I'd probably set it to 30 or 50, I said 30. We'll add our usual email alert notification, set a grace period for a couple minutes, and we'll probably ask for a couple messages in the backlog. So let's go hit the system with Hydra again. Let that run for a couple seconds. If we go back and search, we've got a bunch of new events there. We'll hop over to our email and wait patiently. And we can see an alert appear in our inbox, Ubuntu SSH brute force. And we've got the information, and 3 sample messages from the stream have been provided, and you can see the IP of the attacking system. As a final alert for the Ubuntu system, we're going to see if we can detect someone running sudo-l. It's something an attacker might do to see what sudo permissions they have, if any, on a system. So we ran that command, and we can see that the AuditD did notice sudo-l being run. You can see a couple entries there. The bottom entry there says user equals root, command equals list. And third from the tops has a sudo and a1 equals -l as a parameter. One thing I did want to show here is that within AuditD, a lot of these proc title parameters are encoded hex, and when you convert them, they're the plain text command line being run. It's done to obfuscate or at least hide the command line parameters being run. I did some reading, and you can write a plugin for Graylog to convert those or decode them on the fly. I didn't quite get that far down the rabbit hole. So we'll build our alert logic for this. We'll set it to the Ubuntu Syslog message stream, and we're going to search in the local 0 facility, which is the facility that the AuditD messages are coming in under. And we're going to search on that actual proc title. Now, this isn't necessarily the best way to do something. It's not obvious what I'm searching for here. Someone might be able to add a parameter to sudo-l that would change the hex conversion, but we're just trying to do a bit of a demo here. So we'll set a grace period for a couple minutes, and we'll include one message in the backlog. So back over to our Kali system, and we'll trigger sudo l a couple times. Back over to our email, and we'll just be patient. And there it is. Ubuntu sudo permissions list. Now we're going to shift our focus slightly and head over and take a look at pfSense, the firewall. But before we get into alert creation, I noticed when I was trying to generate events for the firewall that the timestamps weren't coming through properly. So we just did some logging in and logging out there, and if we look at the pfSense events, in the last 30 minutes we get nothing. But in the last 8 hours, you can see some events there, and they're coming through as 157 UTC, which is incorrect since I'm in the Eastern Standard Time Zone. So we're going to create a new pipeline here to modify the timestamp on the fly. We'll call it pfSense timestamp, and I'm going to paste in the rule set there. Now this took me forever to figure out. I'm sure a lot of people could do it much quicker, but I struggled quite a bit. So I commented what I did there. But effectively what we're doing is we're creating a rule where if the event has a timestamp field, we're going to pull the timestamp out, strip the existing time zone, and then apply an Eastern Standard Time Zone and reapply the timestamp. So we're going to manage these pipelines. We'll add a new pipeline. Call it pfSense timestamp, keep it consistent, and it's going to modify the pfSense timestamp. And we're going to edit the connections and hook that up to the pfSense stream. And stage 0 is there by default, so we're going to edit that and add one. The only rule we're going to use is the pfSense timestamp. And you can create a pipeline with multiple stages, multiple rules. And as soon as we do that, we'll just generate some new logout, login events. And what we'll see in Graylog is now the timestamp is coming through properly. So 7 o'clock UTC, which is correct. So since we generated a failed login and a successful login, we're going to base our alert logic on that. For our purposes, I figure we're going to want to know if anyone either tries to log into the firewall, whether it's successful or not. Might be worth alerting on. So I just copied the contents of the failed login, and I'm copying the contents of the successful login to a separate notepad. So we'll head back over to our alerts, create a new definition, and we'll call this one pfSense login activity. It's a filter and aggregation rule, and we'll start designing our search query. Now we know the stream is going to be pfSense, so we'll set that. will be the logic for a failed login, web configurator error. And we're going to say, or the message is probably some successful login message. Successful login star. So we're capturing success and failure. And we'll set that to scan every minute for a minute prior, and we want to know about any results. So we'll add our email notification template. Set a grace period for a few minutes. I believe I set this one to 5 minutes so that I wouldn't catch my previous failure. And we set some backlog messages as well. So now that we're done creating that alert logic, let's go generate some failed and successful login events. And we can see both the authentication error and successful login. And if we wait patiently, we should get an email. And there it is, pfSense login activity. And we can see this one caught the authentication error. And as a final alert for pfSense, I wanted to catch a scenario where maybe someone was running some sort of an Nmap scan against the firewall. So I'm going to use my, we'll call it my external Kali VM. This is on my main network. Its IP address is 192.168.1.108, and you can see I'm running an Nmap scan against the external interface, the WAN interface of the pfSense firewall. So I just wanted to see what type of events would pop up. And you can definitely see a bunch of different block events from varying ports. So I also wanted to take this opportunity to build a dashboard, something that we could use to visualize the results as they're coming in. This is more just for fun than anything else. So we're going to scan on the action block, because that's what we're interested in. We'll set the stream to pfSense, and we're going to look at a bar chart, and we're going to set our rows to the source IP. So we're going to want a bar chart, one bar chart per source IP. And we can see the 1.108 is my external Kali VM. I'm also going to add a message table to filter on similar results, so pfSense and action block, just so we can see what's coming in as the bar chart is taking shape. And this is something I didn't get into at all really throughout the tutorial, but you can shape your tables, save different query results, extract different fields to suit your needs. There we go, so our dashboard's set up the way we want it. We'll just save that for future use. And we'll set it to update every couple seconds. And we'll look back over the last, I think I set it to 1 minute or 2 minutes. Looks like 1 minute. Alright, so let's start building out our alert logic. We're going to call this pfSense port scan. Filter and aggregation. We're going to select the pfSense stream. The reason I'm looking back over 20 minutes is because there was a delay between the recording of these sections, and I wanted to catch the events so that I was sure I was filtering properly. And we're going to do a group by here. We're going to group by source IP, and the reason I'm doing this is maybe you've got 100 different IPs accidentally getting blocked on the firewall at once, and that could trigger a false negative, or I guess a false positive. And what we want to do is filter on IP or group by IP so that if a single IP is hitting the firewall, that could indicate an Nmap scan or similar. So we're looking for 100 block events from a single IP over the course of 5 minutes. And so far we're sitting at 200, so I think I sped the video up here and waited for that to clear. There we go. So let's head back over to our external Kali instance here. And I'm going to set it to the top 15 ports, and I want it to send out 2 probes every second. And this is more just so we can visualize how the messages are being received by Graylog. And this is a separate instance of my Kali subsystem running on my Windows 10 machine. I thought I would use it to simulate a second attacker, perhaps, or a second system scanning the firewall. So they're both running the same command, and what we'll see over on the Graylog side in a moment, there we go, is we've got 1.108 and 1.134 both scanning the firewall, but neither are scanning it enough to trip the alarm. So I did this more so that we could visualize what I meant by multiple systems hitting the firewall. And now I'm just deleting the contents of the pfSense index to save myself having to wait 5 minutes or change the alert logic. Now the next scenario I wanted to test was to send enough probes, enough packets, so that when using both systems, they would both still be below the 100 threshold, but their aggregate would be above 100. And this was just to make sure that my logic on grouping by the source IP was working properly. This is something else you should just get in the habit of doing, is testing your alarms thoroughly to ensure they're working how you expect them to be working. So what you can see here is both 1.108 and 1.134 are starting to pile up probes over the last 5 minutes. And we can see 108 is approaching 60, 65, 77. I think it stops somewhere in the 80s, so 82, just below 100, 86, 88. And we'll assume that 1.108 came fairly close to that, 82. So that's 170 in total. But neither system crossed the 100 threshold, so we didn't get an alert. So we'll delete that index one more time. And then last but not least, we'll fire enough packets from one system to generate the alert. So that should do it. So we'll let that start climbing up, and once it breaches 100, and the next time that alert logic triggers, we should get our alert notification. While this video was running, I noticed 1.140 pop up there. It turned out to be my wife's work laptop. There we go. So we've breached 100, 110, 112, 118. Let's go wait patiently in our email. And there's our alert, pfSense port scan. And if we take a look at that, we should be able to see all the information we're looking for, including the source IP, which would presumably be our potential attacker and would warrant further investigation. Well, if you made it this far, thanks for sticking around. It was a lot of content to cover. Just a quick list of what I went through throughout this video. We did a 2019 install, Windows 10 installations, domain setup, Ubuntu install, Kali install, some Windows domain setup, hMailServer setup with Thunderbird as the mail client, Graylog installation and configuration, NXLog deployment to collect the logs off the Windows systems, Sysmon deployment to get more granular Windows event log information. We did AuditD on our Ubuntu installation along with our Syslog setup and configuration, a pfSense installation for the firewall, a little bit of networking along the way, and Graylog log ingestion and alerting. And I highlighted Graylog install configuration along with Graylog log ingestion and alerting only because that was the initial reason behind this video, was just to show some alerting logic. But I realized that in order to get there, you kind of had to have the whole lab environment set up. And I just made a little note there at the bottom. This is a mile wide and an inch deep, and all that means is I didn't really go into great detail on any of these topics. Perhaps Graylog, perhaps some of the monitoring and alerting, but you could do hundreds of hours on each of these topics if you really wanted to. So that's it. Take care.